Welcome to The Explainer. Today we're diving into a really fascinating thought experiment. We're following the clues laid out in our source material, and it all starts with one startling question that, believe me, leads to some pretty dramatic conclusions. Let's get into it.
So here's the wild premise our source material throws at us. Just imagine it, not a slow, creeping pollution that happens over decades, but a single, massive, catastrophic event. One day, a third of the water we rely on is just gone. Let's follow the chain of logic here and see exactly where this investigation leads. Okay, so before we can even begin to wrap our heads around what losing a third of our freshwater would mean, we kind of have to understand just how precious and rare it is in the first place. You can't really grasp the scale of the loss until you see how little we actually have to work with.
Right, so when you look at all the water on planet Earth, it's pretty shocking. Almost all of it, a whopping 97%, is saltwater. That leaves this tiny little 3% sliver that's actually fresh water. But it gets even more extreme from here.
And this is where it gets really wild. If you take that small 3% of fresh water and break it down, you find out that most of that isn't even accessible to us. Nearly 70% of it is just frozen. It's locked away in ice caps and glaciers. Another 30% is deep underground.
So when you do all the math, what are we left with? A measly 0.3% of all freshwater. That's it. That's the surface water, the lakes, the rivers, the swamps, that humanity really, truly depends on for its survival. So losing a third of that, yeah, that would be an absolute catastrophe.
Okay, but this whole thought experiment, it isn't just about water disappearing. It's about how it disappears. And the central idea hinges on a very specific kind of event.
This right here, this is the key clue in our whole investigation. The source talks about a single star falling from the sky. Now, what does that imply? It's not a gradual pollution problem, right? No. This points to a single point impact. One massive, instantaneous contamination event. Boom. All at once.
And just like that, the logic really narrows our search. We're not looking for thousands of polluted rivers all over the globe. The theory demands that we look for one single, gigantic body of water that's big enough to represent a third of our entire usable supply. So, if we're hunting for one massive source, the next logical question is, where do we even start? I mean, where is the vast majority of our surface water actually located? Well, take a look at this. It's kind of mind-blowing, actually. Lakes hold a staggering 87% of the planet's liquid surface freshwater. 87%. Rivers, for all their importance in our minds, they only account for about 2%. So yeah, if you want to take out a huge chunk of water in one go, a lake is your primary target.
Now, the source does consider other possibilities. I mean, could groundwater be the target? Probably not, right? Given the speed and the scale implied by a falling star, it just doesn't quite fit. What about the mighty Amazon River? It carries 20% of the world's river water, so it's a possibility. But the sheer, mind-boggling volume contained in the world's largest lake systems makes them the most logical suspects.
Okay, so with lakes identified as the most probable target, the analysis starts to zero in on three colossal freshwater systems. Any one of these could be large enough to fit the bill.
And here they are, our three prime suspects. First up, you've got the North American Great Lakes, a massive system that directly impacts over 30 million people. Second, Lake Baikal in Russia, the world's single largest freshwater lake by volume. And third, the African Great Lakes, which together hold the most water and directly support a population of over 200 million people.
So from these three potential locations, the source takes a really interesting pivot. It moves from hydrology to geopolitics. It starts proposing two final theories based on motive. It's no longer just where this would happen, but why. Who would benefit?
And here's where it gets really serious. The source gives us two competing scenarios. The first one is called the superpower collapse. The target? The USA's Great Lakes. The logic is, if you want to destabilize the entire world, you first have to break its leading superpower from the inside, create a massive water and food crisis at home, and its democratic structures could just crumble. But then there's theory number two, the resource grab. This time, the target is the African Great Lakes. In this scenario, a superpower would protect its own water supply while seizing control of Africa's, using it as a powerful tool for global dominance in a world where resources are scarce.
You know, ultimately, after all this complex geopolitical theory, the analysis grounds everything in one simple, terrifying reality.
It all comes back to this. Where there is no drinkable water, people cannot live. Control of water is, quite literally, control of life itself. So, we're left with this final thought. This whole exercise, it offers us two very different visions: internal collapse or external control. And you know, whether you take the falling star idea literally or just as a metaphor, the journey itself is what's so revealing. It really forces us to confront this undeniable and often brutal connection between the resources we absolutely need to survive and the global mechanics of power and control.